So now that we've defined all of the pieces that we need to find in a rational function when we're trying to graph it, we're ready to go. I put a chart up here, and sometimes you won't have the chart, but I put the holes first. You should always look for the holes before you look for anything else. If there is a hole, that gets canceled out and you find zeros, vertical asymptotes, non-vertical asymptotes, everything based on that, okay? And non-vertical asymptotes, you don't necessarily have to use the reduced version, and the same for the intersection. But everything else is definitely, or I should say the vertical, the zeros, and the holes are based on whether there's a hole in the beginning. So the first thing I'm going to start out doing is, if it factors, I'm going to factor, because that's going to tell me if there's a hole. So x squared plus x plus 1 over x minus 1, x plus 1. Okay, so I can already see, because this and this is the same, there will be a hole. There's one at x is equal to 1. So when I'm asking you guys to find the hole, I want you to find the ordered pair. So that means we're going to do, to find the ordered pair, I have to substitute in x is equal to 1 to what is left over. So look, we cancel this out essentially, right? And that means I have to substitute in a 1 for x plus 1 plus 1 in the numerator and a 1 plus 1 in the denominator. So that ultimately, the y coordinate for that is going to give me 3 over 2. So my hole is 1 comma 3/2. Once I have that hole, I'm going to go in and plot that. I know that there's going to be a hole right there. I'm going to draw it in right away, because if the function has a hole, it's going to approach that hole as if the function existed there. The only thing is, if there's a little blip there, you jump over, okay? So it's never going to not meet as if it's a part of the graph. The only thing is that we draw a hole there, okay? Now we're going to find the zeros. So the zeros is where the numerator, so that's of the reduced fraction, is equal to 0. Now in this case, I could use the discriminant to determine, and I can see, okay, b squared, which is 1, minus 4ac, this is less than 0. So there's no real solutions. So that means this one has none. There are no zeros. That means no x-intercepts. That's what that actually means. So maybe that's a good idea just to add to your definition for zeros. Keep in mind, geometrically, where the graph has x-intercepts. If zeros are real. And in this case, the zeros would not be real, so that's not plottable. We're not going to put it in. Now, the vertical asymptotes happen where the denominator is equal to 0 once we have accounted for the holes. So that means I would take the denominator that's left over after accounting for the hole, that is only x plus 1 now, and set equal to 0. So that means I have a vertical asymptote at x is equal to -1. I'm solving for x. And it's not the number -1. It is a line. So you have to write x is equal to -1. You cannot just write -1. That is nonsensical when we're talking vertical asymptotes. It has to be a line. So x is equal to -1. I drew that in. All right. Non-vertical asymptote is, in this case, the numerator has a higher degree than the denominator. So for me to be able to answer this question is actually divide. So the way I'm going to do that is I'm going to do this over here on the side because I'm not going to have enough room. And you can just use the reduced fraction. You don't have to do the original. So I have, look, I can use synthetic division. I can use -1 because the denominator now is binomial. 1, 1, 1. That's going to carry down a 1. -1 times 1 is -1. That's a 0. and then it's going to be 0 and 1. So ultimately, I could rewrite this as x plus 1 over x plus 1. But we're taking the limit as x approaches positive and negative infinity would do the same thing here. That is going to, this will approach 0. So this will start behaving just like x. So remember, it's the quotient only. So I know that my asymptote is going to be y is equal to x. That is right here. That's what it's going to be. Y is equal to the quotient. This is the remainder up here in yellow, and this is the divisor, right? So you have quotient in green, remainder in yellow, and divisor in blue. I need just the quotient. Set y equal to just the quotient. That's how you do that. And then I'm going to draw that in, and that's going to give me a line that goes through the origin with a slope of 1. Oh, terrible drawing, but you guys hopefully are getting the idea. So other points that are helpful to find, for example, the y-intercept. The y-intercept happens when x is equal to 0. So that one is easier, I think, just to put into the original f of 0, right? You're substituting in 0 cubed minus 1 over 0 squared minus 1. So that is going to give me x-intercept. No, excuse me, y-intercept, hello, is 0, 1. So 0, 1, I can plot then. There you go. And then the last question we're going to answer is, does the non-vertical asymptote intersect f of x? So we're basically taking f of x, which is equal to x cubed minus 1 over x squared minus 1. And in this case, you could use the reduced version or non-reduced. I think the non-reduced is the easiest. And y is equal to x, and solving this system. So look, ultimately, f of x is the same. You could write this as y. So you can take x cubed minus 1 over x squared minus 1 and set equal to x. Cross multiply, x cubed minus 1 is equal to x cubed minus x. I'm cross multiplying. The x cubes cancel out, and I know then that x is equal to 1. However, x equals to 1 happens at a whole, so not defined at x is equal to 1. Therefore, the answer is no. It does not intersect the non-vertical asymptote. Because remember, the whole supersedes everything. Same with vertical axes. So now, armed with this information, I know that I have points up here. There's 3 regions. There's region A, no, 4 regions. Region B, region C, and region D, okay? I have where like the asymptote is splitting it into those 4 regions, right? I have points, a hole and a point in region B. That means I know I have graph in region B. I'm going to go in and do my very best to draw. Oh, okay. My iPad is not liking that. Let's see. Why won't it make funny lines there? But I'm going to do my very best to draw going through those holes. And it has to be asymptotic with the vertical asymptote. So listen, it's got to go up. Do you guys see that? And then it's got to follow along. And I know it doesn't cross the asymptote. So it's going to start behaving like this line that it's called the oblique in this case, or slant asymptote. So there's a graph there for sure. I know also there cannot be graph down here in region D, because if I drew graph down here, for example, like this, right, it would not pass the vertical line test and would no longer be a function. So region D is out. It's definitely no graph down here, so that's out. I also know that I have to have graph in either region A or in region C. And the reason why I know that is that this function is just undefined at x is equal to 1 and x is equal to negative 1 based on my denominator over here. So that means it's defined everywhere else. So that means I know that I have to have graph on this part over here somewhere. Now the question is it going to be in region A or is it going to be in region C? Because it has to be asymptotic with both the vertical and the slant asymptote. Well, by deductive reasoning, I know that it has to be in region C. Now, you could go in and test a point, like you could substitute in -2 into the original function and get some value to help you plot the point just to figure out where it goes. So, for example, find f of -2. That's -2 to the third is -8 minus 1. And then -2 squared is 4 minus 1. So that's going to give me -9 over 3, which is -3. So the point -2, -3 is going to be on the graph. Now, do I need that? Not necessarily. Some people like doing it so they know that they're in the right region. But I knew that it was not going to be in region A. And the reason why is because I didn't have any zeros. If I had had graph in region A, then, stroke here. That's what we need to get rid of all of it at once. I would have, if it would have to be asymptotic here and here, I would have crossed the x-axis for that to happen. So that means I would have had a 0. And over here, it says there are none. There are no zeros. So there's no possible way it could have been in region A. So that means we have to graph in region C instead. And again, I don't require that you find that extra point as long as you know the behavior and you have the general shape in there. I'm happy with that, okay? But I just plotted a point. If you're one of those people who feel more confident by having an extra point over there to make sure you're in the right region, great. And if I can't, like I cannot have graph here also at the same time because it would not pass the vertical line test. That's how I know that I don't possibly both have it in A and in C. It could only be in region C.